Hello everybody, welcome into another lesson. Today we are going to review powers and exponents and what they are. So, forewarning, I do apologize if this seems like a review of basic math, but it is very important for what we got coming up, because the next lesson is going to be about prime factorization of numbers, and powers and exponents are going to come in handy for that. And same when we go to factor other numbers and algebraic expressions, we are going to need to know how to understand powers and exponents. So let's go ahead and get started here. So we have 4 times 4 times 4 times 4 times 4 times 4. Okay? So we have how many 4s here? 1, 2, 3, 4, 5, 6. Whenever you have repeated multiplication, that can be expressed as an exponent. So the base is 4. That's the number that's being multiplied. It would be the base. The number of times it's being multiplied is 6 times, because we count 6 4s. It's being multiplied 6 times, so that could be rewritten as 4 to the 6th power. Alright. And then let's see here. Let's say we just have 6. Well, we have 6 by itself. That could be rewritten as 6 to the 1st power. It's literally by itself. You just see 1 6. That's the same as 6 to the 1st power. Alright, now let's say we have k times k. Well, k times k, you see the base is k, that's what's being multiplied, is k. You see it being multiplied twice, because you have k times k, you have 2 k's there, it's being multiplied twice, so it would be the same as k to the 2nd power, is how you could write that. So let's say we have r times r times r times r. So r times r times r times r. Well, the base is r. That's what's being multiplied, so r is the base. Now how many times is it multiplied? 1, 2, 3, 4. So that could be rewritten as r to the 4th power. We'll do one more here. Actually, I think we'll do a couple more here. So we have m times m times m times m times m. So m times m times m times m times m. We have 5 m's there. So first we got to get the base. The base is m. Now how many times does it multiply? We count 1, 2, 3, 4, 5. So this is the same as m to the 5th power. Now let's mix this up a little bit here. We have 2 times x times x times y times y. How in the world are we going to write that? Well, of course, you start out with your 2. The 2 just hangs out by itself. That times x, well, we see x twice, so that's, the base is x. You have 1, 2 x's, so that'd be 2x to the 2nd power. Then we have y times y. Well, the base would be y. We see y times y, so that's y twice. You'd also have y to the 2nd power. So the answer to this is it would be 2x squared y squared is how you would write that. It's all in finding your bases and then multiplying them. Alright. We have the expression n minus 5 times n minus 5 times n minus 5. So we have n minus 5 times n minus 5 times n minus 5. Well, it's being multiplied by itself 3 times. So the base, what's being multiplied is n minus 5. Now it's being multiplied 1, 2, 3 times. So the expression, the exponent expression for this would be n minus 5 to the third power. That's the answer you get, n minus 5 to the third power. One more like this, then we're going to move on. Alright, so you got 9 times p plus 1 times p plus 1. Okay? So we got 9 times p plus 1 times p plus 1. Well, we see 9 is hanging out here by itself. Times p plus 1 times p plus 1. We notice p plus 1 occurs more than once. It's being multiplied more than once. So your base is going to be p plus 1. Now, how many times is it being multiplied? 1, 2. So that'd be p plus 1 to the second power. So your expression in total would be 9 times p plus 1 to the second power. That's how you would write that. Alright, let's shift gears a little bit here. Let's say we have 7 to the second power. You can use your calculator for this. 7 to the second power is the same as 7 times 7, which is going to be equal to 49. So 7 to the second power is, in fact, 49. Alright, we have 10 to the third. So we got 10 to the third. That is equal to 10 times 10 times 10, because that tells you 10 is being multiplied by itself 3 times. So 10 times 10 times 10, which, as we know, would equal 1,000. So 10 to the third equals 1,000. Alright, we have negative 9 to the third power, right? So that's going to be equal to negative 9 times negative 9 times negative 9. So we have 3 negatives here being multiplied. A negative times a negative is a positive, but then that positive times a negative, that's a negative. So we're going to get a negative answer. And remember when we talked about multiplying integers and doing them to different powers, how if it's inside the parentheses, the negative sign's inside the parentheses, and it's to an odd power, such as 1, 3, 5, 7, or whatever, you'll get a negative number. If it were to an even power, you'd get a positive number. But it's to an odd power, so we're going to get a negative number. So let's now figure out what the answer is going to be. It would be negative 729. If you multiply all that by itself, you'll get negative 729 for the answer. Alright, let's do 3 times 4 squared. We have a little bit of order of operations coming into play. We have 3 times 4 squared. The order of operations tells us that the exponent's actually going to be evaluated first before we evaluate the 3. So the next thing to do is you're going to have 3 by itself times what is 4 to the second power. That is 16. 4 to the second power is 16. Now you just got 3 times 16, which is 48. So the answer to this expression is 48. Alright, now let's do 2 times 4 to the third power. We got 2 times 4 to the third power. Of course, the order of operation states we do the exponents first before the multiplication, so you're going to leave that 2 alone, but you'll have times whatever 4 to the third is. I happen to know 4 to the third is 64. So now you're just simply left with 2 times 64. That's going to be 128. So your answer is going to be 128. Alright. How about this one? 2 to the 0 times 10. We got 2 to the 0 times 10. Well, if we remember from basic math, any number to the 0 power, except for 0 itself, is 1. And of course, we're going to evaluate the exponents first, right? So 2 to the 0, that's just the same as 1 times 10. So now we just have 1 times 10. The answer to this is 10. So yes, remember, any number to the 0 power except for 0 itself is going to be 1. Because 0 to the 0 power, that's undefined. We can't define that. Alright, let's take another turn here. Evaluate each expression if A equals 2, B equals 4, and C equals -3. Alright, so we're going to do a little bit of some variable equations here. We're going to substitute some values in for some variables. The first one here, evaluate the expression b to the 4th, right? B to the 4th. Well, it tells you here that b is equal to 4, so you'll substitute the 4 in for b, and you'll have 4 to the 4th. Well, what is 4 to the 4th? Just use your handy-dandy calculator. Understand that 4 to the 4 is the same as 4 times 4 times 4 times 4. It's important to understand that. I think you guys get that, so now we'll just do 4. And most of you on a calculator, if you're wondering, how do I input a power? It's going to be something like 4, then that little caret symbol. 4 caret 4. It's that little caret symbol. That's how you input a power. So that answer would be 256, just as I thought. Okay, so when inputting a power in your calculator, that caret symbol usually does it for you. That's how, so it's the base, what you want to raise to the power, that caret, and then the power you're raising it to. That's how you would do that in a calculator. But I got more. What's the next one? We have c to the 4th. So you're going to have c to the 4th. Well, the value of c according to this is -3, so you just substitute -3 in for c. You'll get -3 to the 4th power. Now, it's important to understand that you don't want to just write -3 to the 4th power, right? Because the negative outside of the power, that makes the whole thing negative. Because that's like a -1 in front of this, multiplying by a -1. It's not the same thing as this, if we remember from review. When you're substituting in a number for a variable, it's the whole thing to the 4th, not just the negative sign hanging out by itself. So the whole thing of -3 to the 4th power is what you'd have. we want to evaluate that. Well, how are you going to do that in your calculator? You're going to do in parentheses in your calculator -3 parentheses, then the caret symbol and then you'll have 4, because you're raising -3 to the 4th power. Well, when you do that, you should get 81, because it's also important to remember that a negative number inside parentheses raised to an even number power, such as 2, 4, 6, 8, 10, what have you, to any even number power will always generate a positive result. So the answer to this would be positive 81. Alright, what's next? Alright, we got 4a to the 4th. How are we to evaluate that? Well, of course you see a equals 2, you're going to stick in 4, you'll have that 4, then where the a is, you'll put 2 to the 4th power. So now we have multiplication times an exponent. The order of operation states that exponent's going to come first before the multiplication. So what is 2 to the 4th? That's 16, so you'll have 4 times 16. 2 to the 4th power is 16. So then 4 times 16, you can do that multiplication, it gives you 64. So the answer to this would be 64. Alright, so let's see. We have b to the 0 minus 10. B to the 0 minus 10. So what you'll do next, you see where the b is, you'll substitute the value 4 in for b. So you'll have 4 to the 0 minus 10. Well, if we remember right, any number except for 0 itself raised to the 0 power is going to be 1. So 4 to the 0 is 1. You'll do 1 minus 10. I should specify we did the exponent first because that's the proper order of operations. So 4 to the 0 is 1, then you just have minus 10. So you'll have 1 minus 10, which we know is -9. So the answer to this would be -9. Alright, how about c squared plus a squared? So we got the expression c squared plus a squared. Well, first thing, you're going to substitute in for c and a what the values are that are assigned. So c is equal to -3. That'd be the same as -3 to the 2nd power plus, what is a to the 2nd power? That'd be 2 to the 2nd power. Alright. Now, before we do the addition, the order of operations states we got to do exponents first. So what's -3 to the 2nd power? We have a negative number inside parentheses, but it's raised to an even number power, such as 2, which it is here. It's going to be a positive result. So -3 to the 2nd power is +9, plus, what is 2 to the 2nd power? That's 4. So now you're just left with a simple addition problem of 9 plus 4. That would equal 13. So the answer to this is 13. These are some very good problems here. Alright, how about 3a plus b cubed? 3a plus b cubed. Well, once again, you're going to substitute in the values for a and b. So you'll have 3 times, what is that value of a? That's 2. Plus, what is b? That's 4. That would be 4 to the 3rd power. So we have multiplication, addition, and exponents. Well, the order of operations tells us we do the exponents first. So you'd be left with 3 times 2 plus, what is 4 to the third power? That would be 64. So 4 to the third power is 64. So now you're left down to a multiplication and addition problem. Order of operations tells us multiplication comes first. So 3 times 2, that is 6. Then you'll have plus 64. Now you just have a simple addition problem. 6 plus 64 is, in fact, 70. So that would be your answer, would be 70. Alright, we have a squared plus 3a minus 1. So we got a squared plus 3a minus 1. Well, of course, we're going to want to substitute the value of a in, which would be 2. We'll want to substitute 2 in for wherever you see an a. So a to the second power, that's the same as 2 to the second power, plus 3 times what is a, that's 2. All that minus 1. Well, order of operation states we do the exponents first. So 2 to the second power, that's 4. Plus you have 3 times 2 minus 1. So next the order of operation states we do the multiplication first. So you'll still have 4, but 3 times 2, that's 6. So you have 4 plus 6 minus 1. Now that we have a simple addition subtraction problem, we just work from left to right and solve it. So 4 plus 6, that's 10. You're left with 10 minus 1, which equals 9. So the answer to this is going to be 9. It's all good to know how to substitute in these variables. Not terribly far from done. Alright, we got b squared minus 2b plus 6. So we got b squared minus 2b plus 6. So of course substitute in whatever the value of b is for b. In this case it's 4. You would have 4 squared minus 2 times 4 plus 6. So order of operations states we do the exponents first. 4 to the second power, that's 16. Then you have minus 2 times 4 plus 6. Next, the order of operations states we do the multiplication first. So you'll be left with 16 minus, what is 2 times 4? That's 8. 16 minus 8 plus 6. Now you're reduced down to a simple subtraction addition problem, which they have the same priority. You can work from left to right. So 16 minus 8, that is 8 plus 6. Now 8 plus 6, that equals 14. So the answer you would get for this one is 14. All right. Then we have, I got 3 more. 3 times b minus 1 to the 4th power. So we have 3 times b minus 1 to the 4th power. Well, of course, first things first. Substitute in your value of b for b. In this case, it's 4. So you'd be equal to 3 times a quantity of 4 minus 1 to the 4th power. Okay. Order of operations states we deal with parentheses first. So we have 3 times what's in parentheses. 4 minus 1 is 3. You have 3 times 3 to the 4th power. Now the order of operations states you deal with the exponents first. So we're actually going to have 3 times what is 3 to the 4th power? We're going to deal with 3 to the 4th power. That's 81. And so finally you're left with a simple multiplication problem of 3 times 81, which would be 243. So the answer to this is going to be 243. I got two more. This turned out to be more than powers and exponents. It turned out to be order of operations also, which I like. Alright, we have 2 times 3c plus 7 to the second power. Well, what we have here is c is equal to negative 3. We have to substitute that in. It's like you're going to have a parenthesis inside a parentheses. What you're going to want to do is turn these outer parentheses into brackets. You'll have 2 times 3, and then the value of c is negative 3. See, because if you had double parentheses, it could get confusing very fast. Alright, that's plus 7 to the second power. Alright, so we substitute in the negative 3 for c. You would have had parentheses inside of parentheses. That's why I decided to change these outer ones to brackets. Now, of course, order of operations states you deal with parentheses or brackets first. So you'll have 2 on the outside. Inside the parentheses, you have multiplication plus a multiplication addition problem. Multiplication comes first. You got 3 times negative 3. That's going to be negative 9 plus 7. You show that plus 7. That's to the second power. Now, we still got brackets or parentheses. That still comes first. So you'll have 2 times what is negative 9 plus 7. That's inside the parentheses. Well, that's just negative 2. All that to the second power. Now, we got to evaluate negative 2 to the second power because exponents come before multiplication. So 2 times negative 2 to the second power. Negative 2 to the second power, that's positive 4. So you'd have 2 times 4, which is a simple multiplication problem. That would just give you 8. So the answer for this would be 8. After doing all the order of operations, you get 8. I got one more. I'm spending a decent amount of time on this because I feel it's important to know how to operate with negative numbers and powers and exponents also. Last one. We got 5 times the quantity of a cubed plus 6. Well, one thing I would do, here's what I would do. Remember the distributive property. Before you even do any substitutions or anything like that, go ahead and distribute this. So when you do a distributive, you'll have 5 times a cubed. You'll have 5a cubed plus 5 times 6, which would therefore equal, because it's 5 times a cubed plus 5 times 6, which would therefore equal 5a to the third power plus 30. So really the equation we have is 5a to the third power plus 30. Now we can go ahead and make our substitution in for a. So you'll have 5 times what is a, 2 to the third power plus 30. Well, order of operations dictates we do the exponents first. So we'd have 5 times what is 2 to the third? 2 to the third power, that's 8. 5 times 8 plus 30. Now the order of operations for this next equation dictates we do multiplication first. So what is 5 times 8? That's 40. You're left with 40 plus 30, which, as we know, 40 plus 30 is 70. Alright, so the answer to this would actually be 70. So it's important to understand with powers and exponents that all that is repeated multiplication. That's all that is. And exponents are a much simpler way to write it and a much simpler way to do your calculations in the calculator. What if I had given you 5 to the 20th power? You think you want to sit there and multiply 5 times 5 times 5 times 5? You know, you get the idea. 5 all the way times itself 20 times. I don't think you do. You'd rather just put it in your calculator as 5 to the 20th power. So, understanding that, understanding how to substitute variables in, how to use the distributive property, how to also, you know, do your order of operations, that's very important. So, that's really all this lesson is. The next lesson we're going to talk about prime factorization of numbers, which that's going to be a new way of factoring numbers that we didn't cover in basic math. But in short, what that guarantees is you'll get the same result every time no matter what factors you pick for a number. So stay tuned for that. I hope everybody has a good night. Take care.